Okay, welcome back. So this is just going to be probably another 4 or 5 minutes here. Um, I'm sorry, I'm trying to get a lot in for you real quickly. I know your time's very valuable right now, but just once again, after you're done watching this video, and hopefully you're taking your notes as you go along, you can head on over to do the Google form, and then you're done with this assignment. If you're done with this assignment, you're basically more than halfway there for the week. So anyway, back to kinetic forms of energy. Mechanical, we say mechanical is kind of like a catch-all. If we don't have a better way of describing it, but we know its mass, whatever the object is, and we know how fast it's moving, we can calculate its kinetic energy pretty easily. That's actually the formula that you were given last time when we're talking about kinetic energy as being equal to 1/2 of an object's mass times its velocity squared. That equation actually comes out of Newton's second law of motion, but I'm not going to try and work on that with you right now. It'd be nice if I had a board to do it with, but no dice. So, if you have an object that's more massive and is traveling at the same speed as an object that's less massive, they will definitely have different kinetic energy, just like momentum. In the case of momentum, it's mass times velocity, though. In the case of energy, if you want to go faster, you need more energy, or vice versa. If you are moving faster, you have more energy. That's also why it's impossible to go the speed of light. You just need infinite energy, basically. As you're moving faster and faster, you need not just that much more energy, but that much times that much. It's a lot of energy. Okay, we're going to move through that as well. I'm trying to cut this down for you a little bit. Sound. Sound is movement of energy through substances and waves. Now, a lot of people think that sound's only in air, but it can be through water, it can be through steel, it can be through solid concrete. It actually moves a lot easier through solid metals and even liquids than it does through air. And it doesn't move through space. Basically, these little particles here, which all these little dots represent air molecules, they're actually much, much, much smaller than that. But when they have, say, something pressing on them, like a speaker cone, which this is representing that, it pushes them back and forth, and these things hit other ones or stretch them out. Basically, they fill the spaces. You imagine just like if you were to push in a bath with water one way, more water will pour in from the other side. And so these waves that come in and out is exactly how sound works. Basically, we're sensitive to sound using our ears. But the idea is there's energy in that motion of those particles, whatever those particles are, whether it's knocking on wood or just talking or singing in the air. I love this video of this little kid here. Sadly, this recording suite that I'm using for free doesn't allow me to play videos like that and have you listen in. But if you type "boy breaks wine glass with voice" into YouTube, I'm sure you'll be able to see it real quick. It's pretty darn hilarious. Even to think, the whole purpose of that, have you ever heard of that before? People singing and actually breaking glass. Just like the Tacoma Narrows Bridge, sound actually has a fair amount of energy in it, and it can cause other things to vibrate with that energy. And that's just one simple proof of that. Okay, tacos. Thermal energy. Thermal energy is the vibration or movement of atoms and molecules. It's not, I mean, we talk about it as heat, but it's really not what heat is. Heat is the motion of energy. It could be any of those things. You can have sound heat even. But in this case, we're talking about thermal energy being the molecules themselves that are moving back and forth. So look at the picture of the guy putting the horseshoe into the furnace. Those molecules are moving more and more. They have more energy. And then if you're talking about tossing a cold horseshoe, these molecules don't have as much energy. Sometimes they have enough energy that a solid will turn into a liquid and it'll melt, or that a liquid will turn into a gas and it will become even more spread out. And I know we've talked about this a couple times this year, but that is thermal energy that we're talking about. So I'm going to continue to go over here. Just to review very quickly, we have the potential forms of energy that are stored up: chemical, nuclear, and gravitational, and kinetic forms: radiant, electrical, motion, sound, and thermal. All right, so a quick check of our understanding here. you take a minute to think each time here of what form of energy is this representing. So, what form does this represent? Pause your video. Okay, now this would represent sound energy. Basically what you're doing in each of these are all wind instruments or woodwind instruments is you create vibrations and push air using your lips, and that air actually just gets amplified through those instruments. At the same time, it's still sound energy that comes from really mechanical energy in your mouth. If you can see the bubbles here, this looks like some kind of a chemical reaction. So this would be what kind of energy then? If you said chemical energy, you're correct. But the chemical energy is causing other forms of energy, maybe heat, maybe sound if you heard it bubbling. And if you don't already know, it's basically you're always going to find connections. Energy is constantly going from one form into another. Another example of that would be, what form of energy do you see when you're looking at a light bulb? The answer is radiant energy. So your eyes are attuned to radiant energy, they can perceive it, but you might even feel thermal energy coming off of a light bulb like this. And that's not even where the energy comes from. It comes from electrical energy. And you wonder, where does that come from? So these forms of energy can help us to explain how that works. And even in your bodies, all this is happening all the time. You have chemical energy getting turned into mechanical and electrical energy. You even produce radiant energy in the form of infrared light, the stuff you can't see. Like a big light bulb that's very dim. You think about the forms of energy here. Take a pause. And if you said maybe radiant energy coming out of it, or sound energy, or electrical energy going into it, even some thermal energy coming off of it. Some of these TVs that are less efficient end up making a lot of thermal energy in the process of producing light and sound. This one, hopefully you get it. Maybe try to take a pause and think, what form is it coming from and where is it going to? And the answer for that would be, it's coming from nuclear energy, which is what goes on inside the sun and on the surface of the sun. And it's turning into radiant energy and shooting out across our whole solar system. In fact, that radiant energy there's so much of it that you can literally see it from billions of light years away, which is what you see every time you look up at the stars. You don't feel the heat from our stars that are so far away, but you certainly feel the heat from ours. Even just a little bit of direct sunlight in a day, you can really feel that warmth, even from hundreds of millions of miles away. So take a pause and think about this. Okay, if you said renewable energy, I'll remind you that is not a form of energy. It's just a way of expressing that it's a type of a resource that can keep coming. So wind energy isn't really an energy form. It's just mechanical energy, basically. It's motion energy. It's that catch-all. Wind doesn't have a lot of mass, but you could measure its mass and its speed, and you could calculate its kinetic energy. And the people that installed this wind turbine certainly did to know that, yeah, you can get enough energy out of that to power quite a few houses. And last but not least, we have a flashlight, which would be taking chemical energy in the batteries and turning it into thermal energy in the filament of the bulb, and then turning it into radiant energy out here. And if you got all those, you're doing pretty well right now in understanding your forms of energy. I would suggest that you go and there's plenty more here. I guess I'll do a couple more. This would be radiant energy getting turned into electrical energy in the solar panel field. Take a second and think about this one. Okay, if it's producing light, which some ovens do that, you have radiant energy. Well, obviously the big one would be thermal energy. But a good example of the fact that that stuff can come from other forms of energy is you could have a gas oven or an electrical oven. And those two forms of energy could produce the same thing, light and heat, which is what you get, radiant energy and thermal energy. Okay, this is maybe one of the more favorite ones. This is what my daughter looks like every time She'll be so sweet until she gets the cookie, and then all of a sudden she turns into a monster. And this would be chemical energy. Some forms of chemical energy are a lot more readily available, like sugar, which is why little kids have such a hard time with it. They get all the energy in the world, and then 10 minutes later, this little girl is going to be crashing hard and being really, really upset, which is exactly why I've still never given my daughter cotton candy, and probably never will. She can have it when she's 21 or whatever. She can be an adult, so I don't have to deal with that nonsense. But for now, just know if you don't have enough chemical energy, maybe you're feeling tired right now, you also need to have enough sleep in order to break down all the chemicals that you get in your food. So yeah, I get it. At this point, this might be the end of the day for you. I hope you have a wonderful day. And the next lesson we're going to be doing is going to be on conservation of energy, which we'll talk about more of those energy transformations and how energy is not lost in the process, which is really cool. All right, take care. Don't forget to do your Google form to let me know that you did this and you did it well. Take care, everybody.